Hello students, beginning with the basics of electrical circuit elements for your basic electrical engineering paper. In this lecture, we will first familiarize you with the common terms that will be used when you are studying this paper. No specific question was asked in the previous year papers of your AKTU examination, but you need to have a basic knowledge before you begin this paper. And please don't forget to subscribe the channel in order to avail many facilities. Okay, now the very first term, electric current. You will come across this term in your whole paper and you should know what a current is. Suppose this is an electric circuit which you can see. It consists of a resistor in series, a voltage, and the arrow is showing you the direction of current. So current is rate of flow of electrons in a conductor. Its unit is amperes, and two types of currents are there: direct current and alternating current. In direct current circuit, you will come across linear variable devices like resistors, whereas in alternating current, you will come across inductors, capacitors, resistors, or their combination. So what is the property of electric current? Electric current happens because of the flow of electrons. These flow of electrons are responsible for the electrical energy which we utilize. For example, electrical energy in a bulb is converted into light energy. Direct current can flow only in one direction, whereas alternating current flows in both the directions. The unit of ampere is defined as 1 coulomb upon 1 second. This comes from the formula Q is equal to IT, where Q is charge, I is current, and T is time. Now, those materials which have large number of electrons and are good conductors of current are known as conductors. For example, aluminium, copper, etc. Those which have less number of these free electrons and are allowing very less current to pass through them are known as insulators. For example, rubber, plastic, etc. And those elements which lie midway between conductors and insulators, having less electrons compared to conductors, are known as semiconductors like germanium, silicon, etc. The most important point is that these electron capacities are held till the time these elements are under the governance of room temperature. Okay, now conductors, insulators, and semiconductors. The conductors offer very low resistance to electric current. Insulators offer high resistance, and semiconductors, which come midway between conductors and insulators, they offer in the middle. Conductors have large number of free electrons, insulators have very less free electrons, and semiconductors have midway. The band gap energy between conductors is very less. Insulators, it is very high, and semiconductor energy band is lying midway between insulators and conductors. Electric potential, it always flows from higher to lower, like water falling down a staircase, coming from higher to the lower end. That means whichever is higher charged, it will flow towards the lower charge in order to obtain balance. So the capacity of a charged body to do work, see, these are charges which are doing work, then this is known as electric potential. So the formula for electric potential is work done divided by the charge involved in it. Unit of electric potential is volts. Potential difference is the difference in potential of two charged bodies. A device that is maintaining potential difference is known as a battery, which is a combination of cells or a single cell. EMF or electromotive force is the force that causes an electric current to flow in the circuit. Resistance is defined as the opposition offered to the flow of electrons, and its very basic formula is resistance is equal to specific resistance into length of the wire divided by its area. The unit of resistance is ohm. Its reciprocal or inverse is known as conductance, and its unit is reverse of resistance, that is mho, MHO. Conductivity is reciprocal of resistivity. The very common and the basic electric circuit elements, resistor, inductor, and capacitor, are now explained in detail. Resistance, you can see in the lab, this is how a resistance looks like. These color codes help you to obtain the numerical or mathematical value of this resistance. Suppose how do I know how many ohm this resistance is? I will judge that from the color coding. And suppose from the color coding, I judge that the numerical value of this resistance is coming out as 22 ohm. And in electric circuits, this sawtooth type symbol represents resistance. At times, even this symbol is used in your numerical circuits which you get to solve. So, if V is potential difference and I is current flowing in the circuit, then resistance is defined as the ratio of voltage is to current. Its unit is ohm. And as per Ohm's law, V is equal to IR. This is how you see resistance in an electric circuit. This is current flowing. This is the potential difference, V. Factors which affect electrical resistance are the cross-sectional area of the conductor, length of the conductor, material of the conductor, and temperature of the conducting material. So these factors affect electrical resistance. Resistivity is defined as the electrical resistance offered per unit length and unit cross-sectional area at a specific temperature. So the SI unit of electrical resistivity is ohm meter, and rho is equal to E into J, where E is electric field and J is current density. Though the two words resistance and resistivity look familiar, but there is a difference in them. Resistance is voltage upon current. Resistivity is EJ. The unit for resistance is ohm. The unit for resistivity is ohm meter. Resistance depends on the length and cross-sectional area of conductor and temperature. Resistivity depends upon temperature. Now, how do I judge the numerical value of a given resistor in the physics lab? I will have to learn this table. It is very easy. It is showing me the color code through which I will find the numerical value of a given resistance. How do I learn it? B. Roy, Great Britain, very good wife. That means B stands for black, brown, red, green, orange, orange, yellow, green, blue, purple, gray, white, gold, and silver. So I will remember the numerical value like this. Black comes out as, we will be taking it as the multiplier for it. Brown, 1, red, 2, orange 3, yellow 4, green 5, blue 6, purple 7, gray 8, white 9. And these are the two tolerance bands of gold and silver. Now, suppose I have been given a resistor and I have to find out its numerical value. So what will I do? I will hold the resistor in such a manner that the tolerance band is towards my right hand side, and I will start reading the colors from left hand side. So the band colors here are in the order of red, black, and gold the tolerance. So I will check out from this table. Red is 2, black the multiplier is coming as 1. That means 2 is red and black is the multiplier. So 2 black multiplier or to the power of 1, and tolerance is plus minus 5% of gold. So the numerical value is 22 ohm plus minus 5%. What is this tolerance? Tolerance is basically how much the resistance can vary from its mean value in percentage. Mathematically also you can find tolerance, which is equal to value of resistor into value of tolerance band. Conductivity reciprocal of resistance. Now, Ohm's law, very important law for electronics. It states that the voltage across a conductor is directly proportional to the current flowing through it. And when we remove this proportionality sign, we introduce the constant R. This law remains valid for physical conditions of temperature remaining constant. And this law is very important. There is a very easier way of learning this law also. We see here voltage multiplier into current resistance. Resistance V is equal to IR. Now, applications of Ohm's law, basically they help us in determining voltage, resistance or current. Ohm's law is also used in DC ammeter and DC shunts to divert current. What is the limit of Ohm's law? The limit of Ohm's law is that it is not applicable for unilateral elements like diodes, transistors, etc. For a non-linear electrical element with parameters like capacitor, resistance, etc., the ratio of voltage and current will not remain a constant. So, those circuits which follow Ohm's law are known as ohmic circuit, and their variation is a straight line. Whereas those circuits which do not follow Ohm's law are showing a non-ohmic variation, and the graph is not a straight line. Power in Ohm's law, the very formula for power is voltage into current, or if I keep the value of I here from the Ohm's law formula, I get P is equal to V square upon R, or if I keep V is equal to IR, then I get the formula here as I square R. All these different formulas help me in solving the numerical. The most common unit of power is watt. Other common used units are kilowatt is 1000 watt, megawatt is 10 to the power of 6 watt. So here power is voltage into current. Voltage is power upon current, hence this division sign here, and current is power upon voltage, cyclic order. And the Ohm's law pie chart, through which you can learn all these formulas and just memorize them, because they can be helpful for your higher exams in order to solve the numericals. Okay, biggest law of Ohm's law is to help us in determining voltage, resistance, etc., which we need for an electric circuit. Capacitance. Capacitor, as we all know, stores charge in an electric circuit. So it is measured by the amount of electric charge that can be stored in any electric circuit. The formula for capacitor is Q upon V, where Q is charge and V is the electric potential. The unit of capacitor is farad, and the most commonly used unit is picofarad or microfarad. Higher the value of C, higher will be the storage charge. So energy is stored in a capacitor. Half CV square is the mathematical formula for energy of capacitor, or even Q square by 2C. Inductance, that is basically, you see the inductance coil here in the circuit. It is defined as the measure of electric current changing at 1 ampere per second, resulting in an electromotive force of 1 volt across the inductor. Its unit is Henry. Basically, L is equal to minus E di by dt, where E is the EMF introduced and di upon dt is the variation of current. So there are two types of inductance, self and mutual. Self is for a single case, mutual is for two coils. So self-inductance is the property of the current carrying coil that resists or opposes the change of current flowing through it. And mutual inductance, when two coils come into picture. Energy stored in the magnetic field of an inductor is given by half Li square. Other forms of inductance can be L is equal to mu into N square A upon L, where mu is permeability of core of inductor, N is number of turns of coil, L is length of coil, A is cross-sectional area of the coil. Mu R is relative permeability, which depends on the material used. Mu naught is 4 pi into 10 to the power of minus 7. These parameters are basically the designing parameters for an inductance, and the unit of inductance is Henry. And other common used units are millihenry, that is 10 to the power of minus 3, micro 10 to the power of minus 6. Electric power measures the rate of electrical energy transfer by an electric circuit per unit time. Formulas, common ones are power is voltage into current, or voltage is equal to current, and putting V equal to IR in the above expression, I can also write P is equal to I square R, or P is equal to V square upon R. 1 kilowatt is 1000 watt, 1 megawatt is 10 to the power of 6 watts. There are two types of powers. Absorbing power, when current enters from positive terminal of voltage, then power is absorbed. When current enters from negative terminal, power is delivered. Okay. Electrical energy, total work done in an electric circuit is called its electrical energy, which is equal to electric power into time. The formulas for electric energy, you can just write them in whichever convenient way you want. The electricity bill which we give is calculated by using how much power we are using. So 1 kilowatt hour becomes equal to 1 unit, common home usage of electricity, how we are calculating the bill. Now quickly let us revise, what did we study today? We studied that electric current is rate of flow of electrons in an electric circuit. Its unit is ampere. 1 ampere is 1 coulomb upon 1 second. Conductors have large number of free electrons. Insulators have less number. Semiconductors lie midway between conductors and insulators. Electric potential is equal to W upon Q. Resistance is equal to rho L upon A. Reciprocal of resistance is conductance. Color code for resistance is B.B. Roy, Great Britain, very good wife. Third term in the resistors color code is multiplier, and the fourth is tolerance. Ohm's law, V is equal to IR. Those circuits which follow Ohm's law are known as ohmic circuits, and those which do not are known as non-ohmic circuits. Capacitor stores charge. Its unit is farad. Inductance is the variation that comes up in an electric circuit resulting in electromotive force, which is E is equal to minus L di by dt. The unit of inductance is Henry. Electric energy is equal to electric power into time. The common unit is watt. Power is voltage into current. Power is equal to V square upon R, and power is equal to I square into R. Thank you.